Hello to one and all. I am Tanmay Desai, a first year student in the Masters in Construction Engineering and Management program at SEPT University, Ahmedabad. As a part of Studio-2, that is Construction Execution Monitoring and Control, we had the opportunity to intervene on a hospital redevelopment project. For the purpose of this presentation, I'll be covering here topics namely poor planning, material and inventory management, and earn value management. Starting with the project brief, the site is located in the city of Ahmedabad in a vicinity closer to famous lake. The site is located inside a medical campus comprising of a medical college, auditorium facilities, hostel block, and existing hospital building. The building are divided into three phases as shown, and for our study purpose, we have covered the building in phase 1. The commencement date for the project was 16th January 2023 and the scheduled date for completion is 13th November 2025. The project cost is 257.17 crores and the type of project contract is an item rate contract. The total site area is 39.8 thousand square meter. Block 1 footprint area is 4.4 thousand square meter and its built up area is 50.6 square meter. It is G+9 structure with two basements. The scope of work of the contractor includes RCC, foundation, diaphragm wall, firefighting, mechanical and plumbing services, masonry work, and plastering and finishing. The building is divided into four pores, namely pore 1, 2, pore 3A, and 3B as shown. For pore planning, the pore bifurcation and the direct cost estimation for formwork in the project are finalized. The pore area has been divided into four zones: pore 1, pore 2, pore 3A, and pore 3B, with a total area of approximate 4.140 square meter. The formwork movement plan shows the two sets of formwork systems are optimized, in which one set is used for pore 1 and 2 while the second set is used for pore 3A and 3B, ensuring efficient reuse and cost control. The direct cost of formwork is comes from three components: beam, slab, and column formwork. Material cost as detailed amount to 3.14 crores and labor costs are calculated at 27.6 lakhs. With the addition of profit and GST, the total cost for executing the formwork including all required materials and labor comes 4.53 crores. The detailed formwork planning strategy and set movement schedule for both column and slab shuttering were calculated. On the left, we see shuttering productivity comes for vertical and horizontal components across all four pores. The productivity per labor varies by component, with the highest productivity seen in vertical shuttering for part 3A at 9.99 square meter per day per labor. The planning for pores shown the ideal planning of four pores on the ninth floor, since the rest of the floors doesn't have all pores left to plan. This shows the slab cycle planning for 17, 25, 20 and 21 days for respective pores by calculating simultaneous work performed for formwork, reinforcement work, concreting work, curing duration, and de-shuttering work. To the right, the set code movement schedule for columns and slabs shown how shuttering sets A1 and A2 move efficiently from the 5th to the ninth floor, reducing idle time between pours. Now, for the reinforcement planning for the project, highlighting peak consumption, productivity, and cost comparison between bar lapping and coupler usage. On the left, we did out the peak reinforcement demand during the construction schedule, with March 2025 showing the highest consumption at 248.87 tons, accounting for 45% of total demand of pour planning of 5 months. We observed reinforcement productivity comes for vertical and horizontal components across all four pores. The productivity per labor varies by components, with the highest productivity seen in vertical reinforcement for part 1 at 0.38 ton per day per labor. On the right side, a cost comparison between lapping bars and using couplers is shown. While the total cost of using couplers amounts to 30.06 lakhs and lapping bars cost 32.25 lakhs, a difference of 2.18 lakhs, thus couplers emerge as the more economical option in this case. In concrete planning, the total planned quantity is 993.51 cubic meter for one floor, including all pours and all components. For rebar coefficient, average of 263.85 kg per cubic meter is observed. Part 3A is the most rebar intensive at 277.79 kg per cubic meter since it have all major shear walls in it. Concrete coefficient stands for 0.94 cubic meter per square meter across all pours on average. The March 2025 is the peak month for executing the max quantities with 1203 cubic meter, which is 41% from the total quantity from 5 months of pour planning, and best labor productivity is observed in part 3 vertical members at 16.94 cubic meter per day with average productivity of 12.4 cubic meter per day. Now for material management, lead time calculation were carried out for three key materials: steel, cement and AAC blocks. The analysis shows that the requisition period, including 1 day for transportation, loading and unloading, is 12 days for steel, 7 days for cement and 6 days for block. The contract includes a price escalation clause for these materials, stating that price adjustments will be made quarterly. It also defines the allowable wastage limits as 2% for both steel and cement and 5% for blocks. Based on reconciliation data, it has been observed that all three materials remain within the allowable materials threshold. The actual wastage recorded from reconciliation is 1.91% for steel, 1.7% for cement, and 3.2% for AAC block, including efficient material handling and control on site. The classical EOQ model indicates that the economic order quantity for steel is 68 tons, resulting in the total ordering cost of 2.01 lakh. When compared with the actual on-site ordering quantity, it is observed that additional cost of 1,871 rupees per year is incurred due to deviation from the classical EOQ model. The price break model suggests that optimal order quantity considering price discounts is 68.69 tons at a minimum purchase price of 58.5 thousand per ton. This results in a total procurement cost of approximately 13.29 crores, which is observed on site on April 2024. The HML and ABC analysis collectively highlights that reinforcement steel and binding wire are high value materials with significant cost implications at indicated by their high unit rates of 50 rupees per kg and 67.9 rupees per kg respectively. These materials along with concrete form the majority of the project's material expenditure. According to ABC analysis, reinforcement steel and concrete constitute 91.2% of the total cost and fall under category A, emphasizing their critical financial impact. AAC blocks representing 6.7% of the cost are classified under category B despite comparing a large quantity. Items like PCC, cement, couplers and binding wire together form only 2.1% of the total cost and are categorized as class C materials. This analysis underscores the importance of focusing on cost control strategies for high value materials to optimize overall project expenditure. Now, for earned value management, two softwares are used, MSP and Primavera P6. From the MSP calculations, the project shows a schedule variance of 29.63 lakhs, indicating a slight delay. However, as the delayed tasks are already completed, it doesn't impact the current timeline. The schedule performance index is 0.81, confirming that progress is slightly behind the schedule and needs monitoring. The cost performance index stands at 1.02, suggesting cost performance is within the budget. On other hand, Primavera analysis reports a greater delay with SV at 49.32 lakhs and SPI at 0.72. The cost variance here is 54.48 lakhs, showing overspending, and the CPI of zero point 0.7 confirms this over budgeting status. Now concluding with summarizing the topics, in pour planning we have calculated the slab cycle of 17, 25, 20 and 21 days for pour 1, 2, 3A and 3B respectively. Carried out the labor productivity for shuttering, reinforcement and concrete at 3.73 square meter per day, 0.26 ton per day and 11.35 cubic meter per day, with coefficient of concrete and steel are 0.24 cubic meter per square meter and 234.71 kg per cubic meter respectively. In material management, we observe from conciliation of all the materials are under allowable wastage percentage. EOQ classical model, this site is having extra cost of 1871 in 1 year by ordering 60 ton of steel instead of 68 tons of EOQ. Price break EOQ model, it all shows that 68 tons of EOQ with 58.5 thousand unit rate per ton will be the least cost for a material which is 13.29 crores. In EVM, MSP shows that project is behind the schedule and project is under budget. On other hand, the Primavera shows that project is behind the schedule and project is over cost running. Due to scheduling method of both software are different, which is CPM and PERT, the variation in cost observed. Thank you so much.